A few more examples for AC method. If we try looking at 15m squared plus m minus 2, we notice that 15 times negative 2 is negative 30, and you notice that you can go down the list of possible factorizations, but if you happen to notice the correct factorization, you can just go for it. So we know 6 times negative 5 is negative 30, 6 plus negative 5 is 1, and so we know we can take 15m squared plus 6m minus 5m minus 2 equals 3m times 5m plus 2, and then we can pull out a negative 1. Remember, we can always pull out a negative 1 or a positive 1. Pull out that negative 1, we get the quantity 5m plus 2, and so we get our factorization is the quantity 3m minus 1 times the quantity 5m plus 2. If we looked at let's look at negative 6 plus m squared, you notice this is in the wrong order. We notice that we can't do anything with this. We first have to put in the order of m squared plus m minus 6, and then we could use the AC method, but we can also just say negative 6 is 3 times negative 2, negative 2, and so we're going to get m plus 3, the quantity m plus 3 times the quantity m minus 2. And so we really do want to be careful about having things in the correct order. If we were going to look at, that one will do, 20a minus 18 minus 2a squared. This one we actually have two options. We could do this, first we need to put in the correct order, negative 2a squared plus 20a minus 18, and then we can use AC method. We know it's negative 2 times negative 18 is 36, and we want factors of 36 up to 20, so we go down the list, 1 times 36, 2 times 18, and we've got it. 2 plus 18 is 20. Whoops. So we get negative 2a squared plus 2a plus 18a minus 18, and so we can pull out a negative 2a, leaves behind a minus 1, plus 18 times the quantity a minus 1, and so we get negative 2a plus 18, oops, we get the quantity negative 2a plus 18 times the quantity a minus 1. We notice that's not quite factored completely. We notice that the negative 2a plus 18, we could pull out a negative 2. And that leaves behind positive a minus 9 times that quantity a minus 1. And so we want to be careful that if we've got those kind of common factors, we want to pull those out. So we actually notice that back at the start, when we had negative 2a squared plus 20a plus 18, 20a minus 18, we could have started by pulling a negative 2 out, which leaves behind a squared minus 10a plus 9, and then we notice that would have been negative 2 times the quantity a minus 1, quantity a minus 9. And so pulling out that greatest common factor can make for a much faster factorization. If we had negative 15m plus 34 negative 15m plus 34 minus m squared, we can rewrite that as negative m squared minus 15m plus 34. Then we want factors of negative 34, that's negative 15. So we know negative 2 and 17 gives us positive 15, so we need positive 2, negative 17. So we get negative m squared plus 2m minus 17m plus 34. So we get negative m times the quantity m minus 2 minus 1 times the quantity m plus 2. And so we get negative m minus 1 times the quantity, this one should have been, the second one should have been m minus 2. Notice if we don't get the same sign, that means we have a problem. M minus 2. And so we could leave it like that. We notice that we could also write it as negative 1 times the quantity m plus 1 times the quantity m minus 2. And so this is a slightly preferred format, but there's not really that much difference. We also notice that we'll sometimes have things that are what we call reducible to quadratic. If we had something like negative 3x to the fourth minus, let's not do that one. If we had m to the fourth plus 10m squared plus 21, we notice that we can think of m squared as equaling u, so m to the fourth equals u squared, so we can think of this as being u squared plus 10u plus 21. That's then going to be u plus 3, u plus 7, because we know 3 times 7 is 21, 3 plus 7 is 10, and then we can replace that u with m squared. So occasionally we can take a polynomial that isn't a quadratic function, degree 2, and we can make it behave like a quadratic function.